Hey everybody, this is Alex Merced from alexmercedcoder.com with some more learning how to program in Dart. So last time we talked about declaring variables and math operators, and I do want to add one thing. While you can generally declare all your variables using the word var, there are two other prefixes you can use for declaring variables. You could use const, which means it's a constant. So if I say const b, where to use that, const o equals 15, okay, that means it's a value of 15, but it can never be changed. That's what const means. Okay. Um, so watch what happens if I try to change it. O equals 10. So I'm now reassigning the variable of O. Even though I declared it as a const, it should throw me an error. Okay. Setter found, not found O. See, it's like it's confused. It can't edit it. Although that particular warning message is odd. Usually, it would say something like you can't reassign a constant variable. But again, the way that errors show up in different programming languages can sometimes give you a signal of how different programming languages treat it. But that's not the only way to declare a constant. You could also use the word final. This is different than other programming languages. This piece right here. This is one of the first sort of substantial differences in Dart. And the final, basically a final or a const you can never reassign. Where the difference will be, I think it has to do with compile time. So in the sense that certain, and I always forget which one's which. I think const, basically the number has to be kind of solid. Like you have to declare an actual value, so that way the compiler knows that value is constant. Well, final, you can't reassign it, but you could enter a dynamic value in that initialization. So it's one, is it like constant in compile time and runtime versus is it constant only during compile time but not during runtime? It's for the purposes of the next few videos, the distinction won't matter too much. I just want to make sure that you're aware that the distinction exists, because as you get further down the rabbit hole, it will matter and you're going to want to learn more about it. Cool. So with that, we can continue with control flow and Boolean operators. So let me go back here and let's change these into some Booleans. Now, Boolean operators are ones that test whether something is true or false. An example of a Boolean operator, so we saw one, that was equals, equality. Does this equal this? Okay, and that's a difference from JavaScript, but this is this is a difference that's more a difference in JavaScript than it's a difference in programming. Most programming languages use this for equality. In JavaScript, you do have a triple equal sign and a double equal sign, which have a slight difference in what they evaluate as true. But most programming languages is just the two equal signs. And then most of these are fairly uniform from language to language. So like less than, greater than, let's see here, where's my greater than? There it is. Greater than, less than or equal than, greater than or equal than, and not equal. Okay, so if I run that, it should give me a bunch of trues or falses. Okay, so working our way back, first one was, is 5 not 5? Well, that's not true, so that's false. Is 5 greater than or equal than 5? That is true. Okay, is 5 less than or equal 5? That is true because they're equal. But 5 is not greater than 5, so that's false. 5 is less than 5, is not less than 5, so that's false. Okay, and again, true is not equal true. Okay, and not only can you do that, but you can do compound statements. So let's say this. Let me cut. Well, I should just do this. I can do 5 and 5 equal 5. So basically, this is saying if 5 is less than 5 and, so both have to be true, 5 equals 5, then this is a true statement. So both must be true. This is saying or. So if I say 5 equal 5, as long as one of the two statements are true, then it is true. Okay, let me actually just delete the most of this rest of this code. There we go. Founding A. Oh, that's right, because I used A over here. So let me get rid of that. Cool. Okay, so there we see that 5 equals 5 is not less than 5, so this is a false statement. Well, here we say is 5 greater than 5? That's false, but it's or 5 equals 5, and 5 does equal 5, so one of the two statements is true, so it returns true. You can use this to evaluate all sorts of things. For example, I was making a tic-tac-toe game yesterday, and I need to check if you win the tic-tac-toe game. So literally, I had to create a whole bunch of ands for it to check whether a bunch of possibilities for how you can win tic-tac-toe are true. So it was like, or no, actually, that one I had to use or. If like any of these following win conditions are true, then it's true that you won. So it's this, or this, or this, or this is true. So you will use those. Cool. Okay, so that's that. Now for control flow. Control flow just means how do your program's just not going to be one big sequence of directions. You could do that, but that often results in you typing up a lot more code and having to fix a lot more bugs and making it a lot harder to edit your code. So always the goal is to write as little code as possible. That used to be the reason you used to do that is because you wanted to use up as little memory as possible, because computers had very limited memory and limited processing speed. Nowadays, computers run fast enough, they process fast enough that that's less of a concern, but you still want to write very efficient code because it's easier to read, easier to debug, easier to refactor, meaning easier to make edits. Because basically, if 2 lines of code changes X, Y, and Z, then you only have to change 2 lines of code. But if 1,000 lines of codes affects X, Y, and Z, then you got to go through 1,000 lines of codes, change it, and probably end up breaking a bunch of stuff along the way, taking a lot longer to fix it. So you want to use all your tools to write as most efficient, straight to the point code as possible, but also readable, because you want other programmers to be able to know what your code's doing. So you don't want it so efficient that people can't tell what you're talking about. Cool. Okay, so on that note, we have if statements, and if statements pretty much work the way they work in all languages. This is, again, most of the stuff here. Once you learn one or two programming languages, you'll notice that 90% of the stuff is the same. The syntax might be slightly different, but even then, the syntax in most languages is fairly similar, because a lot of them derive from like C and C++, and then Java kind of derived from that, and C# derived from that, and everyone derives from all this. So a lot of times, a lot of stuff is very similar. Okay, there are a few languages that kind of go in a very different direction, like if you decide to learn Lisp or something, but most languages are fairly similar. Okay, so the way an if statement works is that basically I'm saying if, then in parentheses I'm going to have a Boolean expression. So it could be, let's say, is 5 equal 5, which as we know will return true. I could literally just write true in there. And generally if I put anything other than 0 or false, it's going to assume it to be true. Okay, all values except 0 and false are true. Just keep that in mind. So if I literally just wrote a string in there and put doggy, it'll treat that as true. Just a behavior you need to be aware of. Okay, if. Let me actually indent this, because technically it shouldn't be on the same line as the void main. That's sort of the initial curly brace. So then it should be one indentation from there, and the stuff in this curly brace should be one indentation from there. Okay, make it nice and pretty. Okay, and we're gonna print. Okay, we'll print a string, say, look, Ma, I'm true. And if that's true, it'll print. But what if you wanted something else to happen if it's false? Well, then afterwards you type in else. And put another curly bracket. In here, we'll just copy this. And that should have a semicolon at the end. Just giving it some space makes it much easier when you give it a nice bit of white space. And again, that should be indented. There we go. Okay, and then we're going to change this to look, Ma, I'm false. So 5 equals 5 is true, so this should print look, Ma, I'm true. Cool. Okay, it still printed it, but it's still looking for a semicolon somewhere where I did not put one. And where is it asking for it? Start line 10. Oh, yes, there is a lacking of a semicolon there. It ran because it never actually had to touch that piece of code, so it didn't get confused, but it's warning me, hey, you should have put a semicolon here. So again, sometimes the code will run, But it'll still say, hey, there's a potential problem over here. You should probably go address that. Okay. Oh no, it didn't run. It was telling me that's what their problem was. Okay, so let's run it. There we go. So look, ma, I'm true. Y equals 5 equals 5 is true. Okay. And notice it doesn't print the false one because it only prints one or the other. This is what we mean by control flow. You're controlling where the program is kind of branching off to. So now we've created like a branch, like a fork in the road. It can either go this way, it can go this way, but it cannot go both. Okay, I don't have to put an else statement. If I don't put an else statement and I just put more code beneath it, it'll print this if it's true, but then just go on to the code afterwards. So if I put more code over here, so if I put another print over here, I'll just say this will print either way because it's after the if statement. This will print either way. So right now that's true. See, look, ma, I'm true. This will print either way. Now if we put a false statement, so let's say is 5 not equal 5, which is definitely false. 5 definitely equals 5. We should say now, look, ma, I'm false. Look, ma, I'm false, but this still prints either way because it's past the if statement. Okay, this is the if statement here. Here's the curly brackets for true. Here's the curly brackets for false. And that's pretty much how that works. Cool. But what if I wanted something to not only evaluate whether something is true, but I wanted to repeat over and over again? These are what's called loops. And there's lots of different loops. I'm not going to go over every single possibility of a loop. I'm going to go over the two sort of main types that people use the most, which is the while loop. So in this case, while, we'll say while, let's create a variable. The way you do this, because you only want it to run so many times, it depends on what you're trying to do, but for today's purposes, we'll say not let, it's not JavaScript, var I equals 0. Okay. So we have a variable named I that equals 0, and as long as I is less than 5, if that's true, then it will loop, or it'll do whatever's inside of my curly brackets. Okay, and then once again, we'll just say print. We'll say, look, ma, I'm looping. But if I do that, I mean, if the variable stays at 0 forever, it'll always be true. 0 will always be less than 5. So this will loop forever, which we don't want to do that because the computer will get really confused. So I want to have something that changes I. So I could create any kind of mechanism I want, but to keep it real simple, I'll say I plus plus. So it means at the end of the loop, so first it'll print the thing, then it'll increase I by 1, and then again it'll go back, check to see if I is this statement is still true. If it's still true, it'll do it again. So let's watch what happens. And of course, semicolons, 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 semicolons. There we go. So look, ma, I'm looping. Look, ma, I'm looping. So what's happening? It says I is 0, so 0 is less than 5. Good. Print ma, I'm looping, then add 1 to it. So now I is 1. 1 is still less than 5. So it does it again. Then 2. 2 is less than 5. 3 is less than 5. 4 is less than 5. So when everything is said and done, it's run that loop 5 times. But then on the last time, I is now 5. I is 5 is not less than 5. So then it does not run the loop that last time. It only runs it for 0, 1, 2, 3, 4, which is 5 times. It does not run it for 5, which is the 6, which would have been the 6th time. Now, if you're going to do a loop, like if you're going to have this kind of structure of a loop, as far as like what takes you out of a loop, where I have to declare this variable and then I increment the variable every time, since that's kind of done so many times and so often, okay, they do have a design for a loop that kind of factors that in. It's called a for loop. So what I could have done is done a for loop instead. And the way that works is that instead of declaring the variable before, I can just declare it in my expression because the expression has 3 parts separated by semicolons. So first, I declare my variable. If it's a variable that already exists, I can just pop it in there. Then there's my expression, which gets separated by a semicolon. And then what happens at the end of the loop? Okay, so this is essentially the same loop, but just expressed differently. So it's saying, okay, for this loop, I equals 0. Long as I is less than 5, keep looping. At the end of each iteration, each trip around the loop, please add 1 to I. So I should get this pretty much the exact same results. And I get the exact same results. And again, anything that's inside the curly braces will loop. So essentially that's all a loop does. And again, there's the for loops and the while loops. There are other types of loops. There's oftentimes what's called a do while loop. So what a do while loop does is that it checks, do comes first. So instead what you're doing is you're saying, okay, do this code, and then do it again if this is still true. So what it does is that even if the statement is false, it'll do the code at least once. That's the difference between a do while loop. So that's usually there. Oftentimes there's switch statements. But again, we're going over the real basics in this round. So for Dart, you do have for and while loops, which pretty much work the same way as they do in pretty much all other programming languages. So I'll see you guys in the next video. Have a great day.